trust me on this. Very often I give terminology talks post-lunch, and even I have a hard time staying awake for it. But two presentations on terminology today that I'm providing. This is the first one of two. This is more of an introductory into what terminologies and terminology services are. This afternoon will be a little more involved specifically on FHIR terminology services, terminology and FHIR and terminology services. So this afternoon will actually be like hitting a terminology service, you know, making some calls, you know, some REST calls, authenticating and querying data. So tomorrow or this afternoon should be, I think a lot of fun, but this is fun too. So let's see. I'm hitting the wrong button. All right, so introductions. So welcome everyone. Thank you for coming. My name's Russ. I work for a company called Intelligent Medical Objects. We do terminology and terminology software. I've worked for a few different terminology companies over the years. My background is a software developer, so I'm a computer science, operating system developer, and decided to try some cool research stuff at Mayo Clinic. Got involved about 16 or so years ago in building terminology applications and learning about terminologies, and I haven't really let it go. I find it really exciting. You can do lots of cool things once you get some infrastructure built. And so I've just been involved with a lot of terminology standards work over the past 15 years. We built a lot of cool APIs at Mayo Clinic, and I was like, you know, I wonder if these would be useful to other people, and it turns out they are. So that brought me into HL7 and met people like Lloyd and Graham, and sort of that's kind of how I got here. Just want to thank a lot of people. So 3 bullet points to thank: thousands. The FHIR community, the HL7 vocabulary community, and of course all of the IMO FHIR developers, people that I work with every day, building cool applications using terminology and reviewing my slides. Okay, so outline again, I kind of touched on this, why terminologies are important in health information exchange. Why do we even care about this stuff? Talk about some of the fundamentals of terminology. What is it that we're talking about when we say terminology or code system or value set? And then ultimately terminology services. So the actual cool stuff, the software that actually makes these things, these codes and value sets move around and be useful to the world. So electronic health data. So yeah, why do we care about this in the first place? Well, electronic health data is very challenging to manage. It's very complex. Data needs to span the entire lifetime of a patient, often from before they're born, and it has to persist long after they pass away. So we have to, you know, track this information, log this information, and it's more than just, you know, bullet points, obviously, on a piece of paper. It's very, very detailed, specific information. It's very much focused on, you know, very comprehensive, so that it needs to track the medical history of the patient, the physical, you know, history, physical, pharmaceutical records, lab data, all very specific, all very different. And so we need to manage and track this over the lifetime of a patient. It can take different forms. There can be audio, video, sound, narrative, and coded data. And it also serves as, you know, the legal record for the patient in a lot of cases, the legal clinical record. So why do we use terminology? Well, terminology helps us provide consistent meaning and promote shared understanding of data. How does it do this? Well, no, we'll get to the how in a minute, but terminology allow us to promote shared use of data. So it allows us to exchange data without losing meaning. It allows us to convert data into information by providing a set of semantic rules that essentially rules and logic that allow us, I'm getting ahead of myself. A set, yeah, back up the truck, Russ, back up the truck. So it provides consistent meaning and promotes shared understanding of data through a set of semantic rules. Let me get to the how. So terminologies define a set of concepts. So a concept can be anything, anything like a unitary atomic piece of information. So we have heart disease as a concept. So there's a concept of heart disease. We have the concept of soft tissue disease. So these are concepts. Concept could be something as simple as a car. So terminologies define a set of concepts, each with a unique meaning. Terminologies or code systems, I use those interchangeably, also define relationships. So heart disease is a concept, heart attack is a concept. A heart attack is a heart disease. So we have relationships, different types of relationships that allow us to link concepts together. Concepts can also have synonymous terms. So we have heart attack. Heart attack is a heart disease. Another clinically accurate term for heart attack is myocardial infarction. So heart attack is a synonym for myocardial infarction. Example that just hit me recently was I had no idea what lateral epicondylitis was. Turns out it's tennis elbow. I knew exactly what that was. So another example of synonymous terms that a lot of non-clinical people like myself understand. So it allows us to define different terms that have that same meaning. And of course, you can have different properties on concepts. Concepts can have all sorts of different properties assigned. Taking a look here, if I actually hit the laser this time, here we have, lateral epicondylitis is an epicondylitis, and epicondylitis is an inflammatory disease. So we can have different relationships that allow us to link concepts together to provide meaning. We have different kinds of terminologies. So we have reference terminologies. So these are the big terminologies that a lot of people are going to be familiar with. We have terminologies like SNOMED CT. We have LOINC for lab codes. We have RX norm for drug codes or medications. So different types of reference terminologies that are used when we want to exchange information and maintain a level of interoperability. So if I want to exchange my diagnosis of lateral epicondylitis, I can use a SNOMED code, and that code, along with knowing that it comes from the SNOMED CT code system, allows the receiver to know exactly what that condition is. They can go and look that up. They can query all sorts of information about that disorder for the patient. We also have, and there's some challenges with some of the larger reference terminologies, though, is they're not necessarily the most clinically friendly things to work with. So a lot of times, people at the point of care in a system, and I hear this from a lot of our customers, and especially when I worked at Mayo Clinic, a lot of the physicians that we worked with, they would be looking at the terms from these reference terminologies and saying, this isn't specific enough. This isn't what I want to say the patient has. And so so that's one of the downsides to a reference terminology is they may not be as clinically specific for use at point of care. So interface terminologies come in. Interface terminologies are going to be very fine-grained. They're going to have a very specific synonymy, and they're going to be very, very clinically relevant. A lot of local terms will be used, a lot of local ways of referring to diseases that may actually be important in that practice or terminology that's used at a specific clinic, but may not be used anywhere else. And so we have different terminologies built for different purposes. Ultimately, you're going to have to use a combination of the two. So if I have a point of care system, I'm allowing my clinical provider to actually enter in the terms that are important to them, that may not have meaning on a receiving system or to a receiving system. And so what we'll do is we'll actually create a mapping between the local code and the reference, the local terminology, the code from the local terminology to the code from the reference terminology. And then we can send both of them, knowing that the receiver is going to know, oh, from the reference terminology, this is the code that I understand, and then I can pull information from that. Just like we have the reference terminologies and the interface terminologies, we have terminologies built for very specific systems or very specific uses. HL7 develops some very specific terminologies that are used for messaging and modeling. Very few groups outside the HL7 modeling community even care about them. But they're very, in that community, they're very important. ICD-10 as a classification of diseases and symptoms in the US is used very much for billing purposes. A lot of billing uses. LOINC, laboratory results, panels, and for nursing. So LOINC stands for Logical Observations, Identifiers, Names, and Codes. It's essentially a laboratory lab coding terminology. Clinical drugs, we use RxNorm, and SNOMED CT for clinical terms. So they're all very use case specific. SNOMED is one of the big ones that covers a very broad range of clinical uses. And the other thing that we see is there's overlap. There's a lot of overlap between different terminologies. So you can't just use one. You have to take into account the fact that we're going to be using multiple terminologies for different purposes. And that's okay because we can map between them, but it does make the selection of the terminology very important. The other thing on mapping, you could have entire day classes on mapping, is a lot of times mappings are very use case specific. So just because you have a mapping between code system A and code system B, that mapping could change based on the use case. There are some examples of that. So we have these great big terminologies, something like SNOMED CT, which I think has a little over 300, almost 400,000 concepts to define problems, diseases, diagnoses, body parts, all just very, very large terminologies. But it's very rare that you need 300,000 concepts. You almost never need 300,000 concepts. So what we're going to do is we want to subset a terminology for a specific purpose. So we create something called a value set. Essentially, a value set is a collection of codes drawn from one or more code systems that you need for a specific purpose. So it's just a set of codes that you need for something. Some examples are things like the diabetes problem patient cohort identification value set. Just a value set that's been defined for identifying patients with diabetes. What are the different traits or conditions that a patient would have that would qualify them for being a diabetes cohort? Heart failure problem, patient cohort identification. Again, another set of codes drawn from one or more terminologies. We can grab some from ICD-10, we can grab some from SNOMED, put them together and say, if a patient has any one of these, we're going to put them in the heart failure problem cohort. Cystic fibrosis laboratory results. What are the different lab results associated with cystic fibrosis? So again, set of codes drawn from a code system for one or more purposes. Value sets are persisted by a definition. So a value set isn't just a list of codes. It can be, but this is actually what kind of I like building terminology services. I'm getting excited because this is actually the kind of stuff I like to build. So value sets are persisted by a definition. So we have a definition, which is a machine processable expression that defines the allowable set of codes in that value set. So it's an expression. We have almost like an SQL, a SQL expression, right? You write your SQL, and that's the definition of the content that I want to receive. Then you execute your SQL, you get your data, and that's the data. In this case, our data is called a value set expansion. That's the actual list of codes that are generated by executing that definition. So we have a couple different ways to define a value set. We can do it extensionally, which is by listing one by one, these are the codes that I want. These are the concepts from the code system that I'm interested in seeing for this purpose. We can also do it by creating an algorithm that when you execute that algorithm generates the codes. We've got a couple examples of that. So an extensional definition here, we have one for, and I apologize for the clinical examples here, clinical quality measure value set for statin allergens. So these are this is the CQM value set for statin allergens. This one's published by the National Library of Medicine Value Set Authority Center. In this case, the Value Set Authority Center is a group in the US that publishes value sets for certain purposes. It's a whole listing of thousands of value sets that are available. So you don't even have to, like, most of the time create these on your own. There are people that actually build these things and publish them through the Value Set Authority Center. This value set's defined as these following RX norm codes. So RX norm being clinical drug terminology. Here are the 7 codes that define this value set. So the cool thing is, surprise, surprise, when we execute that expression, that definition, it returns 8 codes. So, you know, again, no surprise there. This is actually the expansion from FHIR for that value set. So we have we have 7 items in here, and here's the contents. Here's the code system it comes from, here's the code, and here's the display. And there may be other properties associated with these codes that if we want, we can actually go in with this URI and that code, and in addition to the display name, we can query out all sorts of additional information about that code, about that concept. So the cool thing about defining a value set this way is it's always going to return those same sets of codes. So this, for all time, until I change the definition, it will always return those 7 codes. So statin allergies, here are my codes, done. That's a pro. The con is, if there's another statin allergen that comes up, and it gets added to the RX norm code system, so the data in the source terminology is now changed, this definition is not going to pick it up. It's still going to return those 7 things. So as human knowledge continues to advance and as the terminologies and code systems get updated, this value set's not going to return that. So that's a con. The other con on this is it's really tedious to develop. There are some value sets that have thousands and thousands of codes in them, and it would be a real pain to go through all the different code systems that you need and start selecting out codes individually and adding them. It's going to be error prone, and it's going to be really, really boring. So that's where we do something like create an intentionally defined value set. So here we create a definition or an expression, and when we execute that expression, it returns a set of codes. So this example here, we have a value set for nutritional status, again, developed by the National Library of Medicine in the US, published this year. It is defined as 34 concepts. So there's 34 concepts in the definition that someone's gone through and selected, but in addition to selecting those concepts, they've taken the next step and said, I'm going to select this concept, and I'm going to want the children of that concept, because we've talked about earlier how terminologies and code systems can be hierarchical, or in some case polyhierarchical, where they can have multiple parents to a concept. I can say, I want this code, and I want all of its descendants. Or I want this code, but I want to exclude these specific descendants, so I can then exclude certain things if I don't want them. I can say, I want the children of this concept, but I don't want that concept. I don't want the parent concept. I just want the children. So there's different filter rules that we can create, we can apply, and then our terminology server logic is going to go through and start saying, okay, filter out according to these criteria. Bang, here's the result. So these 34 concepts for our nutritional value set end up generating 123 concepts. I didn't list them all here because of the limitations of PowerPoint, but of course, no one really wants to look at 123 concepts in JSON anyway. So here's our nutritional status value set. Some metadata about it, the date, the publisher, the purpose, and here's our expansion. We have 123 items under here. Here's one from SNOMED, here's the code, age more than 65 years is a finding. That's one of the codes that they wanted in there. And again, nutritional status, here's another one from SNOMED, age 19 to 59 years. So this cool thing about this is as new versions of SNOMED CT are released, if I execute this statement, this value set definition, and process it against a newer or older version of the code system, I could get a different set of results. So as our terminologies evolve, this intentionally defined value set is going to give me the ability to actually take advantage of that knowledge. Some of the cons to this process is maybe I don't want to get all the new data. Maybe I do want it to be static. So when I define my value set, I just make sure I say, I want the very specific version of SNOMED CT to be used. So SNOMED CT that came out on January 1st, 2018, that's the version of the code system I want to execute this against all the time. I make that part of the value set definition, and it'll always resolve the same set of codes. So I can have my cake and eat it too. The other downside to this is you need a terminology server that knows how to expand that logic. Because the definition itself isn't the list of codes. You have to execute that expression to actually generate your codes. So FHIR supports this. This is why we're here this week, to talk about FHIR and how to implement FHIR. And FHIR does have support for all these different constructs. So we have FHIR defines components to support code systems or terminologies. We can support value sets and coded data. All of these foundational modules as part of the FHIR terminology model are supported. So we have as part of the terminology model or terminology module, we have the FHIR code system object. So it has a URL. It allows us to access that code system and reference it via URI. It can be versioned. We have metadata for copyright information, who owns it, who's the steward, who's responsible for it, the different properties it supports, the different properties that concepts can support. Different terminologies are defined for different purposes, and as such, they have different properties associated with them. So our code system module or resource, actually, it supports everything that we need to define a code system. And of course, if we have a code system, we need our codes. So FHIR goes that next step. It allows us to code systems can refer to a set, codes refer to a specific code system. So the different ways to represent coded values in FHIR is we have code, coding, and codable concept. And it took me a while to get my head around these three, but there's three different ways of actually referencing coded data in FHIR. So code is, again, this is a primitive data type. So we actually see this used throughout a lot of different resources. In the case of a code, we're just talking about a code. So we're gonna have like an actual, 222980006. That's all we're gonna use. That's what the code is. We don't specify the code system in this case because the system is implied. So this is done in the condition resource for condition dot, I'm trying to think, not condition dot code. Clinical status, thank you. Yeah, so the clinical status is implied, and so we just reference the clinical status. And I think severity as well. So the severity in the condition status, mild, moderate, or severe. So again, one of those three codes because the system is implied. Coding, complex type, in this case, a code and a code system. So we actually use a tuple. By providing the code and code system, we always know that this code comes from, code X comes from code system Y. There's no ambiguity there. And then lastly, codable concept, another complex type. This allows us to attach plain text, synonymy. So it's a collection of codings for the same concept. So we can actually have the display information, what have you. And of course, value set. We talked about those, how to define a value set, what they are. FHIR allows us to select and create value sets from one or more code systems. Again, something like FHIR clinical condition, heart failure, what have you. And lastly, concept map. I include concept map here because mapping is a key part of terminology. Whenever we're using codes, there's always going to be a case where somebody wants to map that to a different code. I would like to see, if I have lateral epicondylitis or I have tennis elbow as the diagnosis, and I use the SNOMED code, is in the condition resource, at some point I'm going to have to map that to a billing code, especially in the US. So good example actually came up recently. I got injured at the gym, went into the doc. The doc spent about 45 minutes working on my case. It was awesome. He was really attentive. He gave me a lot more than the 15 minutes they normally get. And at the end of the day, he couldn't tell me, he could tell me he didn't think anything was wrong. I gave myself an internal concussion. Don't do that. He couldn't quite say nothing was wrong. He's just like, we need to do something. So they ended up sending me for head CT, which ruled everything out and also emptied my pocketbook. But what he did is, as we were sitting there, he said to me, we're just going to call this, and I can't remember exactly the term he used. Essentially, it was just episodic migraine assessment. It was really, really a simple code. And I could see, because they were using whatever, they're moving to Epic now, but whatever system they're using at the time, I could see the ICD-10 code up on the screen. Like he had the actual pick list of things that he could diagnose me with, and he chose a cheap one, which was cool because he spent so much time with me. He could have really run up the bill. So he picked a cheap code. So I kind of thanked him for that. But ultimately, that's going to have to get mapped, right? So if he had a interface terminology, he could have actually entered in something that was more clinically meaningful, and then the mapping to the billing code would go under the covers. So he wouldn't actually have to see that on his screen. So yeah, that's why they're moving to a new system. No, they didn't want to play with the billing codes any longer. So terminology services. So what the heck are these? Well, terminology services is the way we play with terminology. So it's software that can allow us to take advantage of the knowledge in the terminology system. So all the relationships and the logic that defines how those relationships can be used, all that can be implemented as part of terminology service software. And that software can be executed on top of different code systems, different terminologies, to return the information inherent in those code systems. So it's not just a flat list of codes. We can actually infer from those codes that lateral epicondylitis is a soft tissue disorder. It allows us to centralize terminology content. So terminologies are all built for different purposes. They have different intents, whether it's an interface terminology or a standard terminology, a lab terminology, or a clinical reference terminology. They all have different purposes. And this allows us to treat all these code systems using a same standard set of APIs. Makes it a lot easier for querying data when I don't have to have, one set of terminology operations for RX norm and another set of terminology operations for SNOMED, and then I'll have a little small local reference or interface terminology that my clinic uses. I can use the same set of APIs to reference and query that data. Again, they're used by informaticians to create and author content, interface applications to translate, and then clinical applications to select and standardize, and by software developers too. We use them all the time. So just some examples of some terminology operations. So term name normalization. So what's the SNOMED CT name for tennis elbow? Lateral epicondylitis. I didn't know that until this year. We can then do a translation. What's the ICD-10 code for lateral epicondylitis? So this can actually get sent to the insurance company so I get billed properly. So the clinical code is going to be different than, the SNOMED CT code for lateral epicondylitis will be something different, but I can actually then do a translate operation and look up the billing code for that. We can do some other types of data analysis. So what kind of disease is lateral epicondylitis? Is it a soft tissue disorder? Yes, it is. So we can actually query the hierarchy, we can query the knowledge in the terminology and actually make that inference. We haven't, asked anyone about it. We've just done a service query and pulled this information right out of the terminology. What's a good short-term treatment for this? Methylprednisone. Doesn't fix the problem, but it makes the pain go away. So we can actually, infer clinical knowledge. What are some types of treatment for this types of disease? And we can bring those options and make those options available at point of care. And then what is that code? So I want to prescribe this to the patient. Well, I'm going to have to send something to the pharmacy so I can actually go and query that code out. What is the actual code that I can then send to the pharmacy and then complete that order? So all of this information can be queried out of the terminology using terminology services. A couple different ways to implement these that I've seen. We've used both of them very successfully depending on the type of implementation. So real-time terminology services. So you have some clinical application that's going out over the network and querying content from a terminology system, a terminology server. These are great on internal networks. At Mayo Clinic, we have terminology services that run in systems that access that content, all done in real time. It's a great way to ensure that you're getting the most up-to-date data, just like working on websites. New data comes in, you load it into a test environment, and then you'll run all your apps to make sure that the data is not breaking into your code. We've actually seen this with the UCOM code system, where an update, units of measure is UCOM. There was an update to UCOM, and we weren't escaping characters correctly in one of our apps, and boom, the thing blew up. So load the data, test your app. If it works, deploy it to production, and you're set. Works really well. The other way of implementing that we've also done is where you'll actually export data from the terminology service, and the clinical data actually hits against that exported data. So you need to do updates periodically. I need to stay on top of that, but we do this with our value sets that we get from the Value Set Authority Center and the value sets that we get from clinical quality measures. We extract those once or twice a year, load them into our systems, test, and deploy. So a couple different ways of having your clinical applications actually reach out and pull that terminology information and make use of it. Just a few slides left, looking at some of the operations provided by FHIR to support terminology services. So there are terminology service standards out there. There's Common Terminology Services, CTS. Second version, Common Terminology Services Release 2. Colleagues at Apollon have one called DTS, Distributed Terminology System. Different terminology services available that have very, very robust, large sets of operations that you can use. FHIR has scaled that down, and I think they've done a very good job on it by reducing the different types of information that you need to query out of a code system and really boiling it down to the few types of operations that you really need. So looking at some of our code system operations, we can do a lookup. So just get me the details about a coded value. Look, give me this code. Here's the code, give me the details about it. Code validation. Is this code actually real? Did somebody just enter a bunch of 9s or something because they didn't know where to go? Like, is the code that I got in the condition resource an actual real code? Is it an actual concept in the code system? We can test subsumption. You know, we saw this earlier. We have lateral epicondylitis. Is this a soft tissue disease? Soft tissue disorder? Yes, it is. We can test that relationship. Is there a parent-child relationship between concept A and concept B, or another type of relationship? And then matches. Find one or more possible matches given a set of properties. So here's a set of properties about a code. Get me all the codes that have that property. So I can do inference on that, and I can actually build decision support systems based off of that information. Value sets, well, I need to expand that. So we showed how we had that intentional value set definition with 34 concepts in it that expanded into 123. This is the operation that does that. Run and expand on an operation, and we'll do this afternoon. We'll actually run an expansion using a FHIR terminology service and actually look at that expansion happen in real time. And again, validate whether a code is in a given value set. So that validation always, is this a real thing? Is what I got in my, is the data that I got an actual real concept? Translation, moving from concept A to concept B, mapping lateral epicondylitis in SNOMED as a diagnosis code to what lateral epicondylitis is. I think it was what, M7711 in ICD-10 for billing. So what's that translation? And closure is something that I'm still trying to wrap my head around in the FHIR spec. But maintaining transitive closure tables within a code system. So if A is a B and B is a C, A is a B, B is a C, then A is a C. So maintaining those, it's something that we haven't implemented. Not saying that you can't, it's just something we haven't really found a heavy use for, at least in our implementations. I'd love to talk to others if you are implementing closure. In the slides, I provided a non-complete list of terminology services, FHIR terminology services that are available. Our colleagues at Apollon, Value Set Authority Center has FHIR terminology services available, Onto Server, Happy. IMO has a limited terminology service that I'll be demoing this afternoon as part of that terminology on FHIR talk. So just a listing of ones available. And there are others. Actually, Renee Spronk and I were comparing lists today, and we're trying to harmonize them. So before lunch, I'm standing between you and lunch. So really, terminologies do help us. They provide that conceptual framework for unambiguously representing data, turning data into information through the rules in the terminology. The terminology's description logic. It provides consistent meaning for data, promotes shared understanding, so that when I say you get a term that comes across as a condition, the patient has an MI. Is it mitral valve insufficiency? Is it myocardial infarction? Is it that the patient lives in the state of Michigan? What does the MI stand for? So code systems allow us to, using that coded data and the description logic and the terminology, provide that unambiguous meaning. And then lastly, we use software and software services, terminology services, to actually get and manipulate and take full advantage of that data. So with a minute to go, thank you so much. I'm looking forward to spending all week with you, and a lot of people here, and if we want to build some terminology stuff this week, let's seek each other out. Thank you.